Hello everybody, my name is Tamas Mona and I will talk about we-trust environmental suitability, simple and complex model approaches. First of all, I want to mention that this is part of a much bigger project with many collaborators. Environmental suitability models require input parameters. For we-trust, this is temperature, moisture and light. What we're looking for is a continuous presence of moisture, or in other words, dew, with a suitable temperature and light. Our output parameter is an infection efficiency, basically a percentage number. The model looks like this with the simplest way. So basically a multiplication of the light, the moisture, and the temperature part of the model. We will not focus on the light calculation and the light modeling because it requires a much difficult approach. A 3D light calculation costs a lot and its runtime is much longer than the other approaches. So, first of all, our simplest approach is a Boolean method where we take the moisture part and a temperature part. The moisture condition is a precipitation bigger than 0 or the relative humidity is bigger than 90%. But what about the temperature condition? We need a minimum and a maximum range to identify what is suitable and what's not. For that, we use a CMIT document and get the germination part of this table for the stem rust and the stripe rust. Here you can see that there is an absolute minimum and maximum temperature as well as an optimum range of temperature. So, which one we use? We want to use, if we want to use the optimal range of temperature, we will get a well-structured image of the environmental suitability. And if we use the whole absolute range of temperature, we will get just a big black blah without any borders and without any significant structure. So this is too much and this might be too less. And this is for stem rust. Let's look at the stripe rust. Oh, for stripe rust, the optimum range is definitely not enough. And also, the absolute range is too much. So we need something between the two. But how to justify just the numbers between the two range? The best way to do this is to go to a little bit higher method. So basically, we get a semi-Boolean method where we're not taking a yes or no type result. We take the combination of the previous two and we keep the optimum range of temperature and we reuse the absolute minimum and maximum. However, between them there is kind of a relaxation zone. This relaxation zone can be a linear or, as we using in our operational run, is powered by 2. So it looks like this. The results for stem rust is basically a combination of the previous two. So we have some structures, but we don't have that so few suitability that we see before. This is more likely, and this is much better representation for in stripe rust. So we have too few and the two match together as a much realistic result. And what about a real complex method? Is that the previous one is enough, or we want to go to further? So in our work, we adapted a method that we call U-period method that basically asks the question, will be enough moisture for infection in a period of time? So we get that with basically the moisture condition that we used before, but in this time we take it with a range of time. So we use a time window. In our case, this is 24 hours, or in our model steps, it's 8 time step. And we check that in that length, how the moisture condition fulfill. So for example, if it's fulfilled, in this case, for 4th time step, the U period length is 4. And if we step forward, it is 3, 2, 1, and it's getting 0. But it's getting back to 5 and 4 again. And after this calculation, we take these numbers and get an average of temperature for the range of the U period length and apply the temperature condition on that. The same time temperature conditions that we talked about before, basically the semi-Boolean condition. So this is an additional step for the previous method. So how does it look like? It looks like that for stem rust, we get some further structure in this part, also some fewer suitability on this part of the image, but not a big difference. What is for stripe rust? Stripe rust gets some stronger suitability in the higher zones, but get some real big difference, for example, in the north zones. So it has some differences, but not that big that it will hurt your eyes. So what we can say from this, is it worth to take this approach? Because it's quite bigger and more complex. How is the run times? If we compare all the runs for the same domain with the same spatial resolution and temporal resolution for a 6-day long run, we will get these numbers in seconds. What we see that the Boolean and the semi-Boolean methods has just minor runtime differences. However, the U-period method needs 27% more time to complete. And also, because of the nature of the method, it requires an extra day of input. So if we use this method, we basically lose a day of data. As conclusion, we can say that a really simple Boolean method with yes or no conditions is too sensitive for example, for the temperature. So this is too easy and too simple. Semi-Boolean method looks like okay, and it has distinguishable patterns. However, the U-period method has much refined and sharper edges and distinguishable structures. However, we need that extra computational time, and we lose some data, for example, for forecast. Thank you for your attention, and waiting for your question in the end.